Green, it's the color of life. As seasons cycle on Earth, it is the greenness of the planet that is the most notable change. Both on the ground and in space, we see vegetation bloom, flourish, and fall. This satellite analysis of greenness over 1 year shows these subtle transitions over the planet from week to week. This data is colored to represent the amount of greenness on our planet. As summer fades to fall and eventually winter, we see the loss of greenness and even blankets of snow across the United States. Improving our understanding of surface vegetation advances our weather model accuracy, as it provides greater detail on energy transfers between the surface and the atmosphere, which is the ultimate driver of weather. We are now able to see the subtle changes in seasonal vegetation cover, which is important for understanding the amount of fuel available for forest fires. We see the scars and disturbances to ecosystems caused by the natural process of wildfires and regrowth, or, in the case of the Everglades, the reduction in the natural occurrence of fires due to engineered waterways. Since 2012, NOAA, in collaboration with NASA, has taken a tremendous leap forward in measuring global vegetation with the launch of the Suomi NPP satellite. The data from the satellite is providing more detailed views of Earth, not previously possible with NOAA satellites. Continuous data records from previous satellite missions, including the NOAA AVHRR and NASA MODIS sensors, will be used in conjunction with Suomi NPP's VIIRS data to document the changes observed in greenness over time and changes from week to week and over decades. Some changes are natural, and some are man-made. The vastness of the Brazilian rainforest is clear in this data, along with the network of tributaries leading to the mighty Amazon. Eventually, this heavy blanket of green gives way to a mottled patchwork of forest and field. In this view, we can clearly see areas of the Amazon converted from dense rainforest into agricultural areas. These land use changes impact local ecosystems, as well as microclimates and microscale weather patterns. Not only does the VIIRS sensor provide us a detailed understanding of how plant cover changes on land, but also how phytoplankton are distributed in the ocean. Besides their individual usefulness, combining the two different datasets begins to paint a picture of carbon cycling across the planet. Moving across Europe, cities mark the otherwise lush landscapes dominated by agriculture and forest. Mountain ranges serve as divisions between climate zones, where rain and temperature vary greatly between opposing sides, such as the Alps and the Caucasus. These climate transitions are especially clear along the southern edges of the Black and Caspian Seas, as lush mountain regions in Turkey and Iran gives way to the plains of the Middle East. Amid vast deserts, we can see the signature of the Tigris and the Euphrates rivers in Iraq, creating a well-known historical breadbasket in the region. Even the most subtle changes in vegetation from week to week provide meaning to scientists. In the Horn of Africa, the slightest pixel-by-pixel variations from week to week provide early warning for the onset of drought conditions, droughts that can impact tens of thousands of people each year. Early warnings provided by vegetation data are used by global relief organizations to mobilize resources to lessen the effects of drought on populations. As vegetation regrows, it is also an indicator of the potential for malaria, since mosquitoes in sub-Saharan Africa are reliant upon proper vegetative habitat to reproduce and spread the malaria disease. The Indus River Valley in Pakistan shows the signs of productivity, especially in post-monsoon periods, and at its source, high in the Tibetan Plateau, increases in global temperature are resulting in melting glaciers, changing the extent of vegetation in this region. In the dense vegetation of southern and southeastern Asia are the unmistakable signs of the human race. The footprints of towns and cities throughout India and up through China are clearly visible. The United Nations estimates that over 60% of the world lives in this region. Hundreds of islands, both large and small, some just little green dots of lush tropical forest, are scattered through the western Pacific. Even some of the tiniest islands exhibit relatively large spatial variations in vegetation cover due to their mountainous terrain. Australia's red deserts, pale in this representation, are lined by an area of green on the coasts, a thin boundary of habitable land on this island continent. As humans, we do have impact on the color of Earth, but the cycle of seasonal growth continues to beat a constant rhythm on our green planet.